Climate change is no longer just an environmental problem. It's a business risk. Rising temperature affects agriculture, energy demand, infrastructure, insurance, public health, and even investment decisions. But before organizations can adapt to this risk, they first need to understand where the risks are emerging. That question led to this project. In this video, I will walk you through my thought process from defining the problem to selecting the data sets, designing the analysis, and translating 35 years of temperature record into actionable climate risk insights. Which regions are warming, how quickly are temperatures changing, and which area may require greater adaptation measure in the future. Before collecting any data, I started with a simple question, which is, are all parts of Nigeria experiencing climate warming at the same rate? Or are some regions becoming more vulnerable than others? That simple question shaped every decision I made throughout this project. From the data source I selected, to the cities I sampled, the metrics I calculated, and the charts I used. I wanted this project to solve a real problem rather than just demonstrate technical skill. Temperature trends are one of the clearest indicators of climate change, and understanding how those trends differ across regions can support climate adaptation, infrastructure planning, agriculture, and ESG reporting. Rather than building another generic dashboard, I chose a question that sits at the intersection of environmental science and data analytics, which are two fields I am genuinely interested in. Once I had defined my question, the next decision for me was choosing a reliable data source. And since the project focused on long-term climate trend, I needed data that was consistent over time, publicly accessible, and scientifically credible. NASA Power met those requirements for me by providing long-term satellite-derived climate observation with global coverage, making it well suited for this analysis. After this, the next decision was determining the study period. Climate is usually measured over long time scales and not individual years. And according to World Meteorological Organizations, a minimum of about 30 years is generally used to define climate normals and identify long-term climate trend. I selected the period from 1990 to 2025 because it provides 35 years of observation, which is long enough to distinguish genuine climate signals from short-term weather variability, while still representing recent climate conditions. So Nigeria has 36 states and one federal capital territory. Analyzing every location would have significantly increased the project's complexity without changing its primary objective. Since my goal was to compare broad regional warming patterns rather than estimate temperatures for every city, I adopted a representative sampling approach. I selected one city from each geopolitical zone to serve as regional proxy. This allowed me to do meaningful comparisons while still keeping the project manageable. For me, choosing Excel was a very deliberate decision. I wanted the emphasis of this project to be on analytical thinking rather than on programming. The objective wasn't to demonstrate how many tools I could use. It was to show how a clear analytical process can turn raw data into meaningful insight. Excel provided everything I needed to clean the data, perform the analysis, and communicate the findings effectively, allowing the focus to remain on the decisions behind the analysis rather than on the software itself. Every chart on this dashboard was chosen intentionally. Instead of choosing visualizations based on appearance, I asked a simple question: which chart communicates this insight most clearly? So to understand how temperatures changed over time, I used a line chart. And this is because it best represents a continuous time series data. To compare warming across regions, I chose horizontal bar charts because they allow quick ranking and comparisons. And since climate has a strong geographical component, I included a field map to reveal spatial patterns that numbers alone cannot communicate. Finally, I calculated warming rates using Excel slope functions. Average temperature tells us where the conditions are today, but warming rate tells us how quickly those conditions are changing, which is a much more useful indicator when thinking about future climate risk. So after analyzing 35 years of temperature data across Nigeria's 6 geopolitical zones, I found 5 major insights. Every city I analyzed showed a long-term increase in temperature. So this is not just a problem affecting one region, it's a nationwide warming trend.
Among all the cities I studied, Abuja experienced the largest increase in temperature over the study period. This suggests that Abuja may face greater heat-related challenges in the future if this trend continues. Lagos still shows an upward temperature trend, but compared to the other cities, the increase is much smaller. And one possible reason is its coastal location, which may help moderate temperature changes. When I compare all six locations, I noticed that inland cities generally warmed faster than coastal ones. This suggests that different parts of the country may experience climate change differently, which is something I believe policymakers should consider when planning adaptation strategies. Some cities experience bigger temperature swings than others. For example, Abuja and Kano showed greater year-to-year temperature variability. In simple terms, it means their temperature fluctuates more. This makes future conditions a little less predictable and potentially more challenging, especially for planning in sectors like agriculture, health, and infrastructure. One of the biggest lessons I learned from this project is that climate risk is multidimensional. You see, before this analysis, I assumed that the hottest places would also be the ones experiencing the greatest climate risk, right? However, the data revealed a different picture. Lagos recorded one of the highest average temperatures in the study. Yet, it has the lowest long-term warming rate. But in contrast, Abuja had a lower average temperature. In fact, Abuja has the lowest, but also the highest warming rate and the highest variability, indicating that its climate is changing more rapidly over time. And then looking at all of this, we can see that Lagos' high baseline temperature, rapid urbanization, dense population, and exposure to coastal hazard such as sea level rise mean it remains highly vulnerable to climate-related impacts despite its slower warming trend. This project taught me that assessing climate risk requires looking beyond a single metric. Therefore, it is important that both current heat exposure and the pace of climate change should be considered when identifying vulnerable regions and informing climate adaptation and decision making. In summary, the biggest takeaway from this project is that Nigeria is warming, but not at the same rate everywhere. Some cities are changing much faster than others, which means climate adaptation strategies may need to be tailored to different regions rather than using a one size fits all approach.
Thank you very much for watching. My name is Dami Ogben.